12.2, day number 3, example 1c. We're still evaluating the limit. For letter C, we have something that looks a little bit different. In letters A and B, we were working with rational functions. To evaluate the limits, though, even if it looks a little bit different, we should still try direct substitution. You can show your work on this if you'd like, but you should at least check it mentally. If I take 16 and I substitute in for the x's here, in the top I have 16 minus 16, which is 0. Down in the bottom I have the square root of 16, which is 4, and 4 minus 4 is 0. So we get 0 over 0 if we try direct substitution right away. That is indeterminate form. So that just means that direct substitution, the way that the problem is right now, does not work. What we're going to do instead is we are going to try a different method in order for us to evaluate the limit. I'm not going to go through and factor this one. It is factorable technically, and you could use that as a step, but it's not factorable how we usually think of factoring. So with our background, what makes more sense is actually to do some rationalizing. So here's what I see in this problem. I've tried to do direct substitution. I got indeterminate form. When I look at the problem, this is not a rational function because rational functions are polynomials divided by polynomials, and this bottom part of our fraction has a square root in it, so it's not a polynomial. Polynomials don't have square roots. So what I'm going to do instead is I'm going to rationalize. If you remember how we rationalized problems when we're dealing with square roots, how we get square roots out of the bottom of a fraction is by doing this. If you have two terms, like we do here with our square root, we multiply top and bottom by the conjugate of this bottom two terms. We have the square root of x minus 4. The conjugate of that would be the exact same two values, except we have to change the sign in between. So to get started on this problem, you should double check and see if we end up with indeterminate form. You don't have to show any work on that. I did. I plugged it in. I saw I got 0 over 0. And if you have a square root in the problem, what you're going to want to do is multiply the top and the bottom by the conjugate of this denominator. So down here in the bottom, I have a square root of x, and I have a 4. The original had a subtraction in between, so the conjugate is the square root of x plus 4. So I need to multiply top and bottom by the square root of x plus 4. Usually, it's a better visual if we have parentheses around all of those parts. Down in the bottom, we are multiplying something by its conjugate, and we're going to want to multiply that out. Up in the top, though, we have x minus 16 times the square root of x plus 4. We're going to want to leave the top the way that it is. So in these problems, you're going to multiply out the conjugates, but you're going to leave everything else the same. So up here in the top, I'm just going to copy this down as an x minus 16 and the square root of x plus 4. When you go through and you multiply these conjugates together, we're going to want to go through and FOIL this. We have two terms here times two terms here, so that foiling process is what we would use. So if I do the square root of x times another square root of x, that's the f part of FOIL. That would give me square root of x times square root of x. Well, square root of anything times that exact same square root again gives you what's on the inside. The square root of 5 times the square root of 5 gives you 5. The square root of 19 times square root of 19 gives you 19. Square root of x times square root of x, that just gives us an x. That's the f part of FOIL. For the outside terms, that would be the square root of x times that 4. That's the o part of FOIL. And if I do a square root times a number, you can't multiply those together. All you can do is write them down next to each other. So a square root of x times 4 is just going to give us a 4 times the square root of x. That's the o part of FOIL. So far, on the bottom of this fraction, we have the f and the o parts of FOIL. Next, I'm going to multiply our inside terms together. The inside terms together are these two right here. That's the I part of FOIL, that's a -4 times the square root of x. Again, that's a number and a square root, so we can't really multiply them together. We just need to write them down next to each other. So 4 times the square root of x is what we get for the I part of FOIL. And then finally, the L part of FOIL, that would be this -4 times this +4. Those are the last terms. So that's the L part of FOIL. -4 times +4, that's a -16. So if you multiply out those two conjugates, we end up with these 4 terms across the bottom. And if you take a look at the O and the I parts of FOIL, we have a +4 root x, a -4 root x. Those are opposites, so when we combine our like terms and add these together, those are actually going to end up canceling out. And that is the whole point of multiplying by the conjugate. Whenever you multiply by the conjugate, these two terms in the middle, the O and the I parts of FOIL, they just cancel out. And all you really need to multiply out are the first and the last terms. So when you do that step, when you go through and you write down this bottom part, you don't have to give me all 4 parts. When you're multiplying the conjugates, you can just give me first and last. So we end up with an x and a -16 down in the bottom after we get the O and the I parts of FOIL to cancel out. Need a little room there in the top, so I'm erasing all of those arrows and loops. Up on the top, I'm just going to copy that down again. X -16 and a square root of x plus 4. This step right here, where I have listed out the 4 terms in FOIL, that is unnecessary. You don't need to show me that. You could go directly to this x -16. And then from there, you can see in the top and in the bottom, I do have a factor of x -16. Normally, we would look at factoring this bottom, but x -16 doesn't factor, so you could put it in parentheses and then cancel those x -16s out. That would give you the limit as x approaches 16 of the square root of x plus 4, all of that over 1. And now we can do direct substitution. If we take 16 and we plug that in, we'd have the square root of 16 plus 4 on the top over 1. And if you evaluate that, the square root of 16 is 4. 4 plus 4 is 8. So we end up with 8 over 1, or just 8 for our final answer. The work that I need to see on a problem like this is just this bottom line. You don't need to do this step where you're multiplying this part out. Again, you could show more work, but at a minimum, what I would need to see from you is this bottom line.